Hello class, welcome to the lecture on polynomials. If you are here, it means that you've already been to the class on time series and forecasting, which is an application of polynomials. And so at least you have a brief overview of what a polynomial is. And so today we'll go straight ahead to describe what a polynomial is and then find or recognize the various features of polynomials, as well as find a solution to a polynomial. So a polynomial is made up of two words. The first part, which is the poly, and then the second part, which is the nomial. Poly means many and nomial means terms. And so if you put these words together, you have many terms. So a polynomial mathematically is an expression of many terms. And so if I have a polynomial which is given as p of x as ax to the power n plus bx to the power n minus 1 plus up to cx to the power n minus n. Now, since this is an expression is if you take out the equality sign in an equation, then you get an expression. And so since there is no equality sign in this expression, it means it's a polynomial and it's made up of many terms. And so basically, if I'm to reduce the last term, which is cx to the power n minus n will give me 0. So I will end up having cx to the power 0. Now, under indices, any non-zero number to the power 0 is equal to 1. So what this basically means is my p of x is given as ax to the power n plus bx to the power n minus 1 plus add to my plus c. Now, the exponent in our polynomial, or the highest exponent in our polynomial, is what gives us what is known as the degree of the polynomial. All right. So to find the degree of the polynomial, I look at the exponents in the polynomial, pick out the highest one, and that will be the degree. So if you compare all these exponents, we have n, we'll have n minus 1, we'll have n minus 2, we'll have n minus 3, up to n minus n. Now, if you compare all these, you realize that the highest exponent is equal to n. Therefore, the degree of this polynomial is n. Now, the members a, the b, and the c are known numbers. So it could be 100, it could be 1,000, it could be a negative number, any known number. And these are known as the coefficients of the polynomial. Now, aside that, the term in which the highest exponent, which is our n, can be found is known as the leading term. So to find the leading term, you need to find out what your highest exponent is. The highest exponent gives you the degree of the polynomial. Now, aside the degree, the term in which the highest exponent can be found is known as the leading term. Now, since n, which is the highest exponent, can be found in ax to the power n, it means that the leading term is ax to the power n. Now, mind you, ax to the power n is the leading term not because it's the first term you meet when you're going through the polynomial. It is the leading term because it is the term in which the highest exponent can be found. Now, if this is the leading term, then the number attached to the leading term is what is known as the leading coefficient. So in that same polynomial, our leading coefficient will be a. Why is it a leading coefficient? Because it is the coefficient in the leading term. And why is ax to the power n the leading term? It is the leading term because it is the term in which the highest exponent can be found. So let's look at examples. If I have polynomial p of x given as 5x to the power 4 minus 3x to the power 8 plus 16. First of all, let's see if this is a polynomial. Yes, it is a polynomial because 1, it's an expression, there is no equality sign. 2, it is made up of many terms. 3, none of the exponents is a negative number. And so we can go ahead and define the various features of the polynomial. The first one that we want to look at is the degree of the polynomial. And the degree is the highest term in the, highest exponent in a polynomial. So compare the exponents. The exponent over here is 4. In the second term is 8. And then in the third term is 0. Now comparing 4, 8, 0, we notice that 8 is greater than all these numbers. And so the degree of the polynomial is 8. Another feature that we also want to look at is the leading term. And the leading term of a polynomial is the term in which the highest exponent can be found. And so since the highest exponent can be found in the second term, it means that the leading term is minus 3x to the power 8. Not 3x to the power 8, but minus 3x to the power 8. If minus 3x to the power 8 is the leading term, then the leading coefficient of the polynomial becomes minus 3. Right, so something for you to try your hand on. 1, I want the degree. 2, the leading term. And 3, the leading coefficient of the polynomial. 6x to the power 4 minus 3x squared plus 2x to the power 8 minus 4x to the power 9. First of all, what is the degree of the polynomial? The degree of the polynomial is the highest exponent in this polynomial. So the degree is equal to 9. What would be the leading term? I'm going to write LT as leading term. The leading term will be the term in which the highest exponent can be found, which is minus 4x to the power 9. And what will be the leading coefficient? Once again, shortcut LC as leading coefficient. So the leading coefficient will be, very good, the known number attached to the leading term, which is minus 4. Right, so these are the various features of polynomials. We'll go ahead and then give a name to polynomial based on 2 entities. The first is giving a name to a polynomial based on the degree of the polynomial. So we can give a name based on the degree or the number of terms in the polynomial. Now, if you are giving a name to a polynomial based on the degree, then it means that we are looking at the highest exponent in the polynomial. The first one that we'll look at is if the degree of the polynomial, we looked at the degree being equal to n. So here we're going to write n as the degree of the polynomial. And so if we are giving a name to a polynomial based on the degree, it means we are looking at the highest exponent in there. So example, if I have ax to the power n plus bx to the power n minus 1 plus r2 plus cx to the power n minus n. Now, if I'm giving a name to the polynomial based on the degree, if the degree n is equal to 0, now since we cannot go below 0 and the degree is 0, it means we cannot go above 0. It means that our polynomial is of the form ax to the power 0. We cannot add any more terms because if you add another term, it's either we go below 0 or we go above 0. But the degree is 0. And so none of that can happen. Now, any non-zero number to the power 0 is equal to 1. So we have ax to the power, a times 1. A times 1 is the same as a. Now, when we're looking at the various features of polynomial, we said that if this is our polynomial, then A, B, C are known numbers, known as coefficient. So they are numbers. So example is, if I have P of S given as 7 or 8 or 9 or negative 1000 or negative 2/5, then since these are numbers, they never change. It only changes when you have a variable attached to it. That's what we call it a variable. It varies. But these are numbers that do not change. And so if you have a polynomial P of X, which is giving us maybe 6, since this does not change, the term we use for it is a constant. And so if you have a polynomial which is just a constant, then such a polynomial is known as a constant polynomial. Another example, if P of X is giving us negative 8/7. Now this is just a number. It will never change. If a polynomial is just a number, then such a polynomial is known as a constant polynomial. Now if the degree, which is n, is equal to 1, then we have a polynomial that looks like ax to the power 1 plus bx to the power 0. We cannot go below 0. And so simplifying this, we have ps giving us ax, any number to the power 1 is the same number, plus x to the power 0 will give us 1. 1 times b will give us b. Now, since this represents the equation of a line, it means that such a polynomial is known as a linear polynomial. And so if it's the highest exponent is 1, we have a linear polynomial. If the highest exponent is 2, so we have P of S giving us ax to the power 2 plus bx to the power 1 plus cx to the power 0. Such a polynomial is known as a quadratic polynomial. If it's to the power 3, P of x given us ax to the power 3 plus bx to the power 2 plus cx to the power 1 plus a d, then such a polynomial is known as a cubic polynomial. So I'll leave it up to you to give a name to a polynomial based on the degree. If the degree is equal to 4, what will such a polynomial be called? Up to when the degree is equal to 10. Now, another way of giving a name to polynomial is counting the number of terms in the polynomial. When we started, we said polynomial means many terms. And so if I have an expression that has only one term, then such a polynomial will be called, one means mono, term is nomial. So monomial will be a polynomial of one term. An example is x to the power 8. So let's use real numbers. If I have P of x, it's given us negative 4/3 x to the power 2. Since this is made up of just one term, such a polynomial or such an expression is known as a monomial. If it's made up of two terms, then we have P of x giving us ax to the power 3 plus cx. Now, since it's made up of only two terms and we are using the number of terms in a polynomial to give it a name, if poly means many, mono means one, then two terms will be called binomial. If it has three terms, like P of x giving us ax minus cs to the power 4 plus a b, then such an expression will be known as a trinomial. So once again, as an exercise, I want you to give a name to an expression that has 4 terms, 5 terms, 6 terms, up to 10 terms.